Okay, hey, we're going to pick up with where we left off. The homework assignment that goes with this lesson is on page 470. It's 19 through 27, what you're going to experience, and you'll see this with some of the examples we're going to do today, that now when we integrate, we might have to integrate by using substitution. Okay, and actually all of the problems here, except number 25, are going to require you to do U substitution. That's not as difficult as integrating by parts, and we'll review it in case you forget here. Okay, so this first problem is very similar to what we did yesterday. If you recall, anytime you see that infinity symbol up top, we're replacing that with a b. We're putting the limit notation out in front. You should pull that radical up to the numerator and write it as a fraction. Okay, we then said we keep writing this limit notation because we don't actually evaluate the limit until we get to the end of the problem. We perform the integration as normal, which would be adding 1 to our exponent. That's going to bring our new exponent to 1/2. We're going to multiply out in front by the reciprocal. We're going to put that vertical bar with a 1 and a b. Okay, and then we're just kind of treating the b like we would a number. So normally, you plug in the, bigger number. In this case, that's the b for the x, minus, we plug in the lower limit, the smaller number, in for the x, okay? And so at this point, we can kind of look at this and try to see if we can evaluate this limit. I'm just going to clean this up just a tad. It's not super critical that you change this into a radical, but, it could be helpful. I will tell you that if you take the square root of 1 or 1 to the 1/2, that's just going to turn into a 1, so I didn't bother writing that. That's why I just have a 2 there. Okay, the most important thing is you're looking at this now and you're saying, where's the b? If it's in the numerator, we're talking about the numerator growing, which means then this section is going to be approaching infinity. Okay, this is just locked in as -2, but anytime you have any aspect of your limit approaching infinity, then we're just flat out saying this limit does not exist. Okay, very similar to what we did yesterday. Okay, we are not going to do that word problem, but we are going to jump to one that is going to require us to use substitution. Okay, so let's start this out our typical way, putting a b up top with the limit as b approaches infinity. You'll notice what's different about this. When we did use substitution, we did use substitution in 3 scenarios, and I'm going to just jot an example of each of those off to the side. We did it if the exponent on the e was something like it wasn't first degree, so it would be something where this is an e cubed or an e squared. We also did it when we had maybe like a quantity that was in the denominator, and we would pull that quantity up to the numerator, and it would be to the negative first, and then we would choose to plug u in for that, and then it would integrate for our natural log. Okay. On this problem, you can see there is a quantity. It is in the denominator. So that quantity is what we're going to want to choose for u. Okay, so up here off to the side, I'm going to say u is going to be x squared plus 1, and then we take the derivative. Remember, both sides, we do du over dx, and then over here we take the derivative of x squared. Mind you, we're taking the derivative now. I'm not integrating, so this is when you pull that exponent down in front and subtract 1. Okay, the 1 zeroes out, and then, of course, we multiply and bring the dx over to this side. Okay, so we have that stuff set up, and then we come over here and we say, okay, now let me go ahead and plug the u in for the quantity x squared plus 1. Okay, so I'm going to plug u in for that quantity, and then I'm going to go ahead and drag that u squared up to the numerator. Okay, so it's going to look something like this. I'm going to put that u to the negative second, and then I've got an x dx that all come after it. Okay, now remember, here's what we're looking to compare. We have all this extra after the u to the negative second, and we'd like to put in a du in place for that because we can't really have u's and x's together. Oh my goodness, I totally did not put my integration symbol there. We have not integrated yet here. We're prepping this so that we can integrate. Okay, but what I want, look at what du equals. It doesn't equal an x dx. It equals a 2x dx. And so what we're going to need to do is we're going to need to insert a 2 in here so that that will match what du equals. And to counteract that, we're going to multiply in front by a 1/2. Okay, it's been a little while since we've done this. Okay, so let's go ahead, copy down your limit notation. We have that 1/2 we now placed out in front. We have the u to the negative second, but now I'm going to replace all of this with a du, because up here it says a du is equal to a 2x dx. Okay, now I'm in a good spot here that we can go ahead and perform the actual integration. Okay, so I'm going to keep that 1/2 in front. I'm going to add 1 to my exponent. That brings that to -1. And then I'm going to multiply in front by the reciprocal of -1, which is -1. I'm going to put the vertical bar, and then I'm going to kind of clean this up just a smidge here. Okay, so we've got the limit as b approaches infinity. It's going to be -1/2. Okay. You know what, I think when we did this, and I just realized that I forgot to do this, the moment we said we plugged the u in, we're supposed to do like little x equals, okay, because I almost made the mistake here that I wouldn't want to make, which is you should not be plugging this b in for the u. Okay, the reason we put little x equals here in front of these is that is to remind us that we need to go back to the original thing that we said u was equal, and we should plug that x squared plus 1 back in for the u before we plug the b and the 2 in. Okay, does everybody see how I got from like here over to this? I basically was taking this u to the -1, I moved it to the denominator, and then I simultaneously swapped the u out for the x squared plus 1 that it originally was replaced for. Okay, now in the next step, I'm going to plug 2 sets of parentheses. I'm going to plug the b in for the x in the first set of parentheses, and then I will plug the 2 in for the x in the second set of parentheses. Okay. Now I want to look, where's the b? Where's it at? Oh, I see that the b is definitely in the denominator of this whole fraction. And so it's causing the entire denominator of this first fraction to grow. So that means this fraction is approaching 0, but then I need to evaluate what I have left here. And so I can tell I have 2 negatives, so I'm going to make that a positive. And it looks like we're going to have maybe 2 times 5, which would give us an answer of then 1/10 there. Okay, a little bit more complicated because it has integrating by substitution. You're going to see that on several of the problems tonight. Okay. Okay, so on this next problem, there is no substitution, so that's good. But what you'll notice looks different about the next problem is our lower limit is -infinity, and the upper limit is actually a constant. Okay, so what we're going to do is we usually let an a represent our lower limit, and then we let a b represent the upper limit. And so in this case, we're going to take the -infinity out, replace it with an a, and then in front, we're going to say as a approaches -infinity. Okay, now on this problem, the reason we don't have to do u substitution is because the exponent on this e is not, it actually is first degree. Okay, you can see how the exponent on the exponent is a 1, as opposed to if the problem was like an e to the x squared, then that would warrant us to like choose u to be the exponent on the e. Okay. All right, so let's see if we can go ahead and just perform the integration. I'm going to write down the limit as a approaches -infinity. Okay, when you integrate e's, I'm going to keep that 4 there. I'm going to leave a little gap. You're supposed to copy down the original, which is what I kind of have here, but then in front, you're supposed to multiply by the reciprocal of the lead coefficient in the exponent. So I'm putting the 1/2 there. Okay, I'm going to put the vertical bar with an a and a 3. Okay, we're going to clean things up a tad, and then we're going to have to be a little bit careful. So it looks like this is going to combine to be a 2 e to the 2x. Okay. Okay, so I'm going to keep with the limit notation, 2 sets of parentheses. I'm going to substitute a 3 in for the first x, because that's my upper limit, and then I'm going to substitute an a in for my second x. Now, here's where we're going to have to be a little careful. Okay, I'm going to write this one last time. I'm going to fill this in just 1 second there. Okay, I'm going to leave that blank for right now. This is 2e to the 6th. okay, minus, okay, now here's where this gets a little tricky. If you look back, look at what A is approaching. A is approaching a negative number. That's saying if you were to plug in a negative number for that A, and then plug in a number that's more negative, so like -1, and then plug in -2, and so on. Okay, look at where the A is though. See how the A is in the exponent? If we plug in and I'll go ahead and put this here. If we plug in a negative number for the A, that's going to cause the A to be negative. So I'm going to switch colors here. It's like I'm distributing this negative sign on my infinity symbol, and I'm going to put it in here so that I can see that that is making the exponent be negative. Okay, so I changed this so that it's A approaches positive infinity, but I put the negative sign over into the problem. I'm sorry, I'm going to write this one last time, because when I make that exponent a negative, look at what that does now. That now tells me that this E belongs in the denominator. By the way, the 2 doesn't go with it. That's totally separate. Okay, it's really important that you're seeing that E to the 2A is actually in the denominator. So now if you look back and you say, well, if I were to plug in bigger and bigger numbers for that A, look at where the A is. The A is now in the bottom of the fraction. That's causing that fraction to approach 0, which means my answer is 2e to the 6th, which is about 806.86. I'm sorry, 0.86 there. Okay. Let's try one more of these. This is going to kind of wrap up the notes page here for this. Again, we're going to put an A here at the bottom. We're going to be doing limit as A approaches negative infinity. This is another problem that we do not have to worry about integrating by U substitution. Okay. So I'm going to copy down the 12, leave a space, copy down e to the 3x, and squeeze in there the reciprocal of 3. Okay, we're going to combine this together so that this would be the limit as A approaches negative infinity of 4e to the 3x. Okay, all right, now we can substitute in. I'm going to do my 2 sets of parentheses. I'm plugging in the 1 first, and now the A is going in the second spot because the A is the lower limit. Okay, here's where I'm going to switch colors to emphasize this. Since the A is approaching a negative infinity, I'm going to take that negative sign, I'm going to take it out of there, and I'm going to put it with the A, but I'm putting it in front of the 3 there because it just makes more sense there. Okay, because it's really saying you're supposed to be plugging in negative numbers for the A, which is going to make the exponent on the E a negative value. Okay, so that tells me in the next step, if that exponent is a negative, then I need to be moving this to the bottom of the fraction. So that's going to be underneath the 4, it would be e to the 3a. Okay, so again, now if I'm plugging in bigger and bigger numbers for that a, that's causing the denominator of my fraction to get bigger, which means that's approaching 0. I'm just left with 4e cubed. So my answer is 4e cubed, which is roughly 80.34. Okay. If the problems ask you to say whether the limit is divergent or convergent, don't worry about that. Okay. Divergent just means the limit doesn't exist, and convergent means it is converging to whatever your answer is that the limit does exist. Okay. Have a good one, guys.